All right, cool. Hey everyone, we're starting 20 past. Sorry about that. Just trying to figure some stuff out. Okay, how's everyone doing? How are the assignments? How are the labs so far? Feedback. Andre.
That was a little hard.
A little hard. Okay. Someone put their hand up back there.
Can you just give like a 40-second recap of events and like what they do, how we call them, and their purpose?
Sure. Make a Piazza post, and I'll do that.
Okay.
Who else? Any other feedback? Divi.
I mean, in regards to feedback, I think the pace of the class is good. Yeah, like the guy said, sometimes it gets overwhelming in certain things. Like, for example, there's a lot of terminology. Especially for me, like, I am studying the fundamentals on the side. So I think it's a little difficult in regards to that sense. But other than that, I think just keeping up with the labs, there's a lot to learn in that sense too.
Understandable. Yeah. Understandable. Okay, so hopefully this lecture should help with testing out functionality, understanding how things happen, especially external calls. Interactions between smart contracts are usually dubious and hide behind this black box of interactions. And so this should help you uncover some of that. Of course, testing in itself is a task, and it's dubious how testing works as well. But hopefully this will help you uncover some stuff and be useful in some way or another. All right, and this is what it's going to look like. We're going to also talk about tokens if we get enough time at the end. And tokens are exciting because that's probably what has generated all this hype about blockchain, especially on the Ethereum network as well. Okay. So testing.js, what do we mean by .js? JavaScript. Okay. So JavaScript. JavaScript has been a big part of what you've been doing, whether you know it or not. So not only is Solidity JavaScript-esque, you have been using JavaScript underlying a lot of the infrastructure as well. Now, why is JavaScript important? Why is JavaScript useful? Not Solidity. Why is JavaScript useful? In general. It's asynchronous. Okay. Okay. I'm thinking about like use case though. Like, what is it used for mostly?
It's like used for the web.
For the web, right? And most apps are web-based, and so you want to be able to have this like very, very smooth integration with other frameworks. So you can use React. You can use things like Backbone and other things. So basically, integration is a big part of this. Testing happens with Mocha. Who's familiar with the Mocha framework? 3 people in the room. Okay, that's bad, but also it's good. You can learn best practices straight off the bat. And then Chai is used for assertions. It's not too important, but we can also get into it. Okay, so first things first. What I consider the most important thing in any language is printing. And the way you do that is you log it. So console.log. That's how you're going to print. And we're starting off with a little bit of basic JavaScript syntax, just so everybody's on the same page, before moving into contract-specific JavaScript syntax. Okay, so use strict. For those who've used JavaScript before, what is use strict? It's also on the board if you want to read ahead, but sorry?
Be strict in syntax.
Yeah. So throw exceptions before runtime, basically, just so that you can correct errors before you get to actually, deploying your web app. And what are callbacks?
Once you finish your asynchronous call, you make that function call?
Yeah, so what callbacks can be described as is, this is a good example, where you literally define a function inside the function header. And so you can see it here where we've got the function describe, which is a built-in function. We have the first argument be a string, user. And then we have the second argument be another function with its own body and definition. And you'll see this pretty often. And you can even see like how it's nested as well, right? You do multiple callbacks in one block. Okay. So this is an example of how you'd use it. you define a global variable, all user data, which is a list, and you define the function log stuff, which takes in an argument user data, and it's defined, if it's a string, just print it, or log it, I guess, and if it's a list or an object, just loop through it and print all the items. Okay, and then the way you'd use it in a callback is you'd say you have this function, get input, and you can basically input log stuff into there if it's predefined, but you could have also just defined a nameless function within the get input that did the same thing as log stuff did. So this is sort of just demystifying how JavaScript works and the common syntax you'll see on a day-to-day. This confused me and a lot of friends I know a lot when we first started using JavaScript. So hopefully this will speed things up for you in the process. All right, a few keywords. Let versus var. Does anybody know the difference? Vivi.
Let's kind of a constant, you can't change it. Var is a variable that you can update.
Okay. Close. That there's like a little bit more nuance to it in the back. Yeah.
Let only defines the variable for like the next couple of lines.
Yeah. So let is kind of like a local variable, and var is more of like a global scope. So the difference is scope.
So you can change the let. So let is a variable, not a constant.
So constant actually has a very specific keyword. So over here you'll see you say const 5 and you try to change it to 6 and it throws an error. And then the let versus var differentiation is more about like scope.
I just know it like Swift.
Whoa. Yeah. Hey. All right. And you'll get a lot of practice with let versus scope. Whose cats is this? Okay. All right. Moving on. Yeah.
So basically for the let, it's like, so you mean by scope, you mean like, let's say you have a function and you have a let variable defining it. If you have another function inside the class, then that cannot access that let variable.
Let's see.
Go with the
Yeah, so JavaScript has kind of like loose terms in terms of what scope is. I think practice makes perfect in this case. I wouldn't be able to tell you right off the bat. I think in your example, if you have a function and then an inner function inside of that, let is accessible within that inner function, but not outside of that function. Whereas var maybe, for example. And like that's an example on the board right there. Okay, so some Mocha-specific syntax, describe and it are built in. And with tests, you want to have sections, right? You want to have sections of tests where you call a suite, basically. So you want one suite to test some specific functionality, but within that suite you have multiple tests, right? So describe is used for the overall suite of tests that you're going to run, and each it is the actual test case. Does that make sense? So describe is sort of superficial. It lets you group together test cases by criteria, by what you're testing. And it is the test case itself. And before each, after each are all test hooks. And so before each, we'll do what? It's in the name. Right, exactly. Before every test, before each, we'll run some setup, right? So say you want to define a list of variables ABC every test. You don't need to literally copy-paste that line. You can just put it in a before each block, and it'll run before every test. Clear so far? Same with after each. Okay. Cool. So here's a question for you folks. We have two examples. And the syntax, again, is somewhat convoluted for first-timers. But do try and see if you can guess A, B, or C whether the before each hook would run once for each describe and once for each it, or once for each describe, or once for each it. Does that make sense? Do the choices make sense?
Say that again?
Yeah, so it could run before each it, ignoring the describes. It could run before each describe, ignoring all the its. So if there are multiple its nested within a describe, it just runs once. And lastly, it can run before both. It can run once before a describe and once before an it as well, in the back.
What does it do?
So it, again, is the test case itself, and describe is the group of test cases. So you would usually have multiple its nested within a describe, or multiple describes with multiple its nested within it, but take that and nest it inside a describe. So you can have a describe followed by a nested describe, followed by a nested it case in that describe, just in case you have like a supersuite and subsuite. And this is up to you how you want to define them. You'll see later on what they look like when you actually run them. They are relevant for clarity. So yeah, does anybody have any thoughts? A, B, or C? B?
Yeah.
Before every describe? Okay, so that kind of makes sense, right? You would run a setup before an entire suite because it's assumed that you're going to set up for that entire suite somehow. Does anybody have any other guesses? Or does anybody agree with B? How about I do this? Who thinks A? One person. Who thinks B? More people. Who thinks C? Both. Okay, a few people. So the answer is A. Congrats to the one person in the red jacket. It runs before every executable. No matter how nested it is, the before each will run before every executable. The reasoning for that is that if you do a setup, the setup will only apply to that test case, and it doesn't carry over unless it affects a global scoped variable. So ideally, you'd want to do the setup before every test case, if that makes sense. Does that make sense? Okay, awesome. Now, try assertions. To be being is that which. These are all just syntactic sugar that let you make assertions more clear, but also some of them have usability. So, for example, in this, not inverts whatever output you get. So it's similar to the not in Python or having an exclamation mark in a conditional. So when you're expecting something to be something else, instead of saying, take this example right here. Instead of having to check whether it's equal to something else, you can just check whether it's not equal to something. And then this example is good. So expect 2 to not equal 1. That would be a bad way to use not, right? Does anybody not understand why using not in this way is bad?
I don't understand.
Yeah. So say you're looping through numbers, right? An infinite set of numbers, right? And you want the test case to check whether it's equal to 2. It would be better to check whether it would not be equal to 2 as opposed to checking whether it's equal to 2, because it would loop through many, many numbers in that case. So in that case, that's a good use case for not. In this case, expect 2 to not equal 1. Well, what if we had 3 there instead? That is also not equal to 2, but it would return true, right? The assertion would return true because it's not equal to 1. So in the bottom case, it doesn't account for every possibility. Anyway, basic stuff. I'm sure this will become more intuitive if and when you use it. I personally don't use trie assertions, but it's up to you whether to do so or not. And of course, the syntactic sugar part comes in. Like, if you look at the bottom line of the top box, that does not include. So only like not and include are relevant statements, and the rest are just there to make it more clear what's going on. Are you folks fans of syntactic sugar? Things that don't actually functionally do anything but make code more clear? Hands up for syntactic sugar. Jeez, wow. Hands up, not syntactic sugar. Okay. Some cases it's good, some cases it's bad, and we'll see later on a case that I actually like using it for. Okay, asynchronous programming. What is asynchronous programming?
Where you run a function, but then it has to make a call to a backend server or something, and so there's a bit of a delay between when you run it and when you get the return value.
Perfect. In simple terms, it's not synchronous, right? And actually, if you do a search on the docs, on the Truffle docs, for asynchronous programming, you get 0 results, which is really, really disheartening. If you don't know what asynchronous programming is, you're stuck, right? But that's why you're here. Okay, so we can start off this conversation by asking ourselves, what is a promise? And then we can also say, in an asynchronous fashion, we'll get back to you on that, okay? So we're going to run something else right now. We're going to run with something else, and later on we'll find out what a promise is. Okay, so say, take the synchronous example. What is synchronous code? Right, it's the way we're all used to writing code in 61A and 61B, right? Sequential, one line after the other. And so here you define the synchronous function, then you run the synchronous function with 5 as the input, then retval gets set to 6, and then you call a different function, and then that has to be blocking, right? So you'll wait 10 milliseconds, 20 milliseconds, 30 milliseconds. It's still blocking, right? Because you need to wait for this frame to like return to you. Does this make sense so far? Okay. And these are not accurate numbers, so don't quote me on that. Okay, and then finally it returns back to you. You get retval, and you finish off the... yeah, there you go. You get your return value. Awesome. Okay, so it's blocking. And what is our answer to that? Okay, so this is what a promise is. It lets things run in the background and return to us only when we need them, basically. So we can do other stuff while we're waiting. And that speeds things up, especially for testing. You want to be running asynchronously, so you can test multiple things at the same time and do it quickly, because you're going to be testing quite frequently. And so the overhead of waiting for tests to run piles up. So a promise at any one time could be in one of 3 states. It could be pending, so the asynchronous operation is still running. It could be resolved, so it's completed and it returns something back to you. And then lastly, it could be rejected, which means that it finished but it was unsuccessful, it errored, or some exception was thrown. Make sense? Cool. All right, so we have an asynchronous function now. And this is, again, Python. We're not using JavaScript for this, just for familiarity's sake. We define an asynchronous function, and we get 5. We input 5. We increment it by 1, so we have 6. We run it, and then, so we can continue, because it's just a promise right now. Right? We don't know what's going on behind the scenes in this black box, but we can just continue, right? Oh, wait. This is a problem, right? We can't actually, because it's a promise, it's not an int. Does everybody see why this is a problem?
Well, you haven't gotten a value.
Yeah, exactly. Say that again?
You haven't gotten a value back.
You haven't gotten a value back, right? we said that it could be pending or it could be resolved. And in this case, it's still pending, right? It's still not resolved. It's still not an integer. Okay, let's backtrack then. Let's add in some new code. So asynchronous programming is kind of like a slightly different paradigm where you need to change the code slightly. You can't just use asynchronous functions the same way you would use synchronous functions. So we added in a few new lines. And what this has let us do is we now have a temporary variable that we can increment. And then at the very, very end, we resolve the promise, and then we increment it. Does this make sense? Who's confused?
Looks like all we did was just move the evaluation of the promise to the end. But in the whole, it looks like the same sequence, same runtime.
Yeah, so the thing here is that you allowed all the code to run and do the things that were necessary for you to do before actually bringing it back. So it may be the case that at the end, it still takes 30 milliseconds, right? But now you've done other things as well. So that's fine. And this is obviously like a very, very simple example.
So if you don't need the result, it's time you just do a bunch of other stuff.
Exactly. This is a very simple example. Okay. Question over there.
So when you run promise bid, does it start running in the background, or does it just wait until the end?
So that's a good question. It does run a bit in the background, but that's like not to get too deep into how asynchronous calling works, but it does run in the background. And there's actually there are claims by Mocha that it speeds things up by factors of something ridiculous, like 100x or something, even more probably. But I don't really buy that, but who am I? You can try it out, though. You can try writing out your code in a very synchronous way. And then you can try writing your code in an asynchronous way. And Truffle test will actually give you measurements for how fast your code runs. And you can check it out. Yeah. Amina, did you have a question?
Yeah, so retval is set to n+1, but it's never used again. So we don't use that variable anymore?
So retval is used. Retval, yeah, you're right. It's never used again.
Okay.
Yeah. We did.
So this asynchronous call stuff, is it actually just running it on a different core? Is parallelization is what's making it run fast? If you have a single core, it's not going to help you. So what exactly?
Yeah. I would think of it more as a multi-threading kind of thing. Again, Mocha is not clear with the implementation, but I would think of it more as context switching. So, for example, you're running Google Maps, right? You don't want to wait for just the route to load and then the actual map itself. You want to switch between them very, very quickly so that you can see sort of the route and then sort of the map and be able to piece things together.
But context switching just adds overhead if you're not using multiple cores, so this is not going to be faster than.
It does. It does add overhead, and the purpose of this is so to go into lower level things. So when there's a cache miss or something, there's overhead there, and you're hedging your bets that the overhead of switching is going to be less than the overhead of recovering from that cache miss, for example. Anyway, 61C and 162 stuff, for those of you who've taken that. Okay. So basically, we should understand now what functions are. They're purely there for efficiency purposes, and we'll see how the paradigm that we're going to be using changes the way we program. Okay. Also, errors may come up when you run tests with promises and you don't recall them back. So make sure if you get any error that looks like this, expected empty curly braces, that you're actually calling your promises back. Okay. So what used to happen is people would run .then commands, where .then waits for a promise to return before executing what was in the .then parentheses. But this is really messy. It can get really, really nested very, very quickly. Does this make sense? So before each, you would do a db clear, and then you would do whatever. So you would do the db.save Toby Loki Jane. Does this make sense? Okay. Nowadays, people use async await, where you tell it at the very beginning. You say this is an asynchronous function, so I'm going to be using await calls. And basically, what await does is it waits before progressing in a sequential manner. Does this make sense?
So wait, so it calls an asynchronous function and then just waits?
And just waits. So what is the issue with that?
It's just synchronous.
So yeah, this mimics how you program synchronously, right? So the more awaits you do, the more it's looking like synchronous code, which is okay, I guess. Whatever. Where would async awaits be useful?
When you need like a value. Right?
So when you need to do other computation. Yeah.
Value.
Yeah, exactly. Okay, so just use async await, no need for .thens. And this clarifies a few things in the ecosystem that a lot of testers get caught up with when starting up with Mocha. Like, oh, there's this .then functionality, there's this async await, which one do I use?
So is everything assumed to be asynchronous? Or like
Yeah, Mocha just naturally runs asynchronously. Yeah. Okay, again, so async await is an example of syntactic sugar, but I actually like it because it leads to non-messy code that would otherwise happen with .then statements. Does that make sense?
Oh, so it doesn't do anything, really.
So if you look at the implementation, async await breaks down into .then statements. So they're functionally not different. They just look better.
Look better. It's like a
Yeah, exactly. Okay, and this was, you can look at the link right there. There are many, many ways of doing this. Again, this is why I want to try and avoid getting caught up with the syntax. Just do async await. And that was like a real message I sent last year when I was first learning about this. And maybe the impact isn't really there. Just look at that link and you'll know exactly what I'm talking about. Okay. So now we go on to, we've covered, Mocha, the basics, in a hand-wavy way, which is fine. So testing smart contracts. In JavaScript, okay, that should say in Solidity. But this is what it looks like in Solidity. So you can write your tests in Solidity, right? And it says don't do this as a subtitle. We'll get to why that is. But you could deploy a contract to the Ethereum network that tests functionality of your other contracts, right? What are some issues with that, just off the top of your heads?
You can't change your tests.
You can't change your tests. You can deploy new contracts, though, that test, that correct bugs and stuff. You have to pay gas to run your contracts, unless it's on a test net, right? In which case, that's fine. But I like the way you guys are thinking in the back.
Is Solidity not asynchronous?
Solidity is not asynchronous. Okay.
Can you simulate it being asynchronous?
You simulate it being asynchronous. Okay. Okay. Another issue is who's testing the tests in that case, right? And that, I think, is the biggest worry, that when you deploy smart contracts, no matter how much you want them to be deterministic, they do sometimes exhibit non-deterministic behavior. For example, quote-unquote race conditions that we covered, I think, last week in the security lecture. So, again, that's a problem with smart contracts. But you can do this, and this is a legitimate way of testing. So the keywords here is, in Mocha syntax, you would define contract, and you'd have the name of the contract and function accounts, and then in the curly braces you'd have the body of that test suite. You'd also need to require, which is the syntax in JavaScript where we like import the contracts that we're testing. And then you get access to a lot of built-in functions and attributes at the very bottom using Web3, which we'll talk about next week. So in short, contract, you should add that to your knowledge of like it and describe. Contract does a similar thing, where you have the contract, and within that contract you have multiple describes, and with each describe you have multiple its. Does that architecture make sense? Cool. And then artifact.require is just an import statement, basically. And then .call, interesting syntax that you use for non-transactions. So things that you want to test that don't actually change the state of your contracts. So if you ever use .call, and then you test for a certain change, you'll probably be wondering, oh, why are my tests failing? I called this, right? Well, the reason is because you use .call, the state did not change, right? So don't use .call if you want like a variable change to happen, or someone's balance to go up or down, for example. And going back to this syntax, function open paren accounts, that's used to access the accounts variable, which for things like Ganache instantiates a list of 10 accounts, which you can add to, but instantiates a list of 10 accounts. So if you want to access multiple accounts, so accounts square brackets 1, 2, 3, you can access multiple accounts. And then using the tests, you can program in multiple behaviors that can get very, very complex. So you can act as an adversarial node and an honest node, and program in some interactions between them, and mimic attacks, and things like that. And hopefully you'll be able to see that in the tests from like this lab, yesterday's lab, if you take a look at the tests. And contract.address, I mentioned we get access to some special attributes. Contract.address is one of those attributes. It gives you the address of the current contract you're on. And then value of allows you to retrieve a number from the contract balance. Okay. And then there's this special curly braces syntax that you can add to probably any function as an extra argument, if that makes sense. So say you have a function func that takes in one argument n. What you end up doing is you put in n as like 5 or 6 or 7 or whatever, comma, a second argument that isn't coded in there, that is basically this JSON-like object. These curly braces. They specify what address the call is coming from. So if you want to use multiple accounts, this syntax is useful. And how much value they're sending from their accounts. Additionally, when accounts are instantiated, you yourself can specify how much balance they start off with. And this is a note for like simulation networks. So like Ganache, for example. Again. Does this make sense? This is how you specify who is sending the method and how much they're sending. Is it clear why this is useful for tests? Who's confused about the usefulness of this? Who thinks this is useful? Let's do it that way. All right, a lot of people don't think it's useful. Why is that? Interesting. No response. But this is super important. So I actually do need like someone to say something. Like, what is the blocking issue here in understanding this thing? Because if you're to write tests, you will most certainly require this argument. Right.
Yeah, so I get that it's useful, but I was trying to figure out how to do this within the tuple console.
Uh-huh.
I mean, it's probably in the docs, but how do we do this within the tuple console? Like, how would we interact with, let's say, betting contract to specify some value?
Yeah, so you would usually need to write tests in your testing folder.
Oh, so I have to use tests.
Yeah, preferably. But you could also do it in tuple console, I suppose. But you would include this argument as like an extra parameter.
Okay.
Is the basic way you would do it in any method call.
But the point is, we do this, like, it's better to use tested to interact with it. Or
Yeah. The tuple console should just be used for like quick and messy interactions that you want to just check. Okay. Cool, and this is just an overview of async await versus .then. And you can see that you can do the same things, but in a much cleaner way with async await. Hence the purpose of syntactic sugar. Okay, and yeah, Solidity, don't do this. Yeah, okay. So things to note, Solidity can be used to cover inter-contract relationships. So one Solidity contract can test whether another Solidity contract worked the way it was intended to work, but they can't test how the entire architecture works together. And we'll get to what that means exactly in a second. Feel free to sign in. Take a minute for that. Okay, and moving swiftly along, again, dev decal 4, dev decal 04, dev lec 04, sorry, and then async is the code. So best practices, let's speed through this. Just a quick note, there is an ERC, Ethereum request for comment, and it's basically like a PR or an issue you would open up on GitHub, and it's calling for a new framework for testing. So there are individuals working on this, and actually the people responsible for frameworks like Truffle and I believe Embark, Dapple, they're all working on this as well. So this should be out sometime soon. Maybe there's some progress. But let's get into TDD, test-driven development. Does anybody know what this is? This isn't just limited to smart contract development.
It's like you write tests before you start actually writing code, and then you'll write the code to make sure it fills that test.
Yeah, that's the basic idea. It goes in a cycle where you write the tests first, you see if they fail. If they fail, you make corrections, and then you refactor, and then you write more tests. And that means that you're testing very granular functionality, and you're going for 100% code coverage, basically, where every single line in your product is tested. And people really like to take this to like new levels. Like if you do TDD, there's like all these explanations, and most of these come from like the old world of programming, where people do things very traditionally, but it is generally considered good practice. So the main takeaway, though, don't get too worried about it. The main takeaway, though, is you want to be testing every single line, making sure that everything does what it's supposed to, be very specific and very granular. And then, of course, make them run as fast as possible by refactoring code. What do you test? Smart contract security. So last week's lecture was all about security. Those are the main pain points you want to be talking about. And testing, making sure nobody can attack your contract, but also you want to be checking functionality, make sure things, like if somebody pays a contract, they're able to get their money out, things like that. Okay, unit and integration testing. Who knows what the difference is?
Unit test specific functions, right? And integration test several functions working together. together your whole program.
Exactly, exactly. So unit tests test specific functions, and integration tests test how your entire system works together and is interoperable. And so the parallel here is that, you could use unit tests for solidity, since contracts can test the functionality of other contracts, but not really how things work together. And then you can use JavaScript for your integration tests. But the best way is just to forget about solidity and to just use JavaScript for everything, right? You don't need to worry about deployments. You don't need to worry about gas. You run everything locally. All the testing is done in a succinct and reliable way.
And this is in Truffle?
In Truffle, yeah. Using Mocha. Yeah. Okay, need for speed. So you want to speed up your, you're at 0 right now, and you want to go really, really fast with your tests. It's important to, the gauges are also at 0, by the way. I don't know what's going on in this picture. But it's important to be efficient with your code. So setup and teardown, the reason we talked about that is so that the lines are easy to read. This is not really the speed at which your code runs, but the speed at which you can test and improve on your code base, right? Use things like you define let at the very top, and because those are in the scope of the entire thing, because you're going to be changing them. And so you don't want to be taking up space by defining new variables every time. So you just define let at the let good, not poison, and poisoned, which all describe variables that are going to be changing throughout. And then you mess with them inside each of the test cases. This is generally considered the best practice. Oh, also for numbers, you want to have them. Want to have set values defined at the very top. So big amount will always be some ridiculously high amount, and this is useful for testing arbitrarily large values of whey, which is a denomination of ether. Small amount, and if you want a little bit of granularity, you want to have a big small amount, whatever the case is, and then 0, of course. And then readability. What do I mean by readability? So if you look at where it says contract, you'll notice that it says good auction test. You want to give names to all your tests, and you want to name every single test that runs. You want to say what it does and what it's testing for, so that when it fails, you know why it's failed. And this is an example of how I structure my tests. And you can structure them differently if you like, as long as they're readable. Does this make sense? Excellent. And like I said, it actually tells you how quick they run. Great. Okay, extra tools. Let's not linger on this, but if you want to go for 100% code coverage, you want to use Solidity Coverage, which is an experimental tool that literally tells you every line that has been tested and not been tested. And you can find that at the GitHub link. And Ganache is, that's a question for you folks. What is Ganache? Right, a local blockchain, but it also has a front-facing GUI, a graphical user interface. It used to look like this, and now it looks like this. And the great thing about Ganache is, so you can see everything, all the addresses, all the balances at any one point, but also the most important thing, for me at least, is that you can move blocks forwards and backwards, which is something you could not previously do on the predecessor tool, which was TestRPC. You could not test time. So if you had a betting contract, for example, where the oracle would check the bet after n days, you would not be able to fast forward the blockchain to account for that. But now you can. That's fantastic.
What do you mean fast forward the blockchain to account for her?
Yeah, so you can change the daytime of the actual blockchain. Yeah,
What
yeah.
you can't do on actual, can you not change the anything in a previous block in actual blockchain? How does that?
So you can fast forward the block number.
Or the block number. Oh,
Yeah,
gosh, okay.
yeah, that's how it would work. Okay, cool. And then I want you to take everything we've talked about and maybe not, but maybe throw it out the window because over the weekend, this past weekend, somebody at ETH Denver, a hackathon in Denver, went ahead and made espresso, which seems to be better than truffle tests in every way. And this is just how the industry works. It moves at a breakneck pace. So by next semester when I teach this, maybe it'll be entirely in espresso. Who knows? And this is what it looks like. The tests run in real time. So need for speed. Really, this is what encapsulates that statement. Anyway, okay. So we do have time, I think. For tokens. Great. Can somebody close the door, please? Awesome. So, what do you folks know about tokens? Don't make me pick someone. Or do, I guess. Christy, what do you know about tokens?
What do I know about tokens? I invest.
Okay. Tokens can be an investment. Sure. What else?
They're like a coin that kind of rides on top of another blockchain and can be used just like for internal purposes for some organization.
Okay. So they are implemented on the application layer of a blockchain, and can be used for some functionality specific to that. I think that's pretty good. And so how do we get to this place? How do we get to this position? What is the platform that most tokens choose to build on? Ethereum, right? And why Ethereum? It's easy. I heard in the back. Yeah, it's easy. It has a high-level, friendly-looking language that compiles down into bytecode, so nobody needs to mess with opcodes or anything like that. It's generally, it's not the best, but it works, right? It works, and that's the least you could ask for. And you can program smart contracts. And actually, the point of Ethereum, the philosophy behind Ethereum was the smart contracts. It was not the currency. It was not Ether to begin with. It was so that people could run smart contracts in a trustless way. Whether it succeeded in that or not is up in the air. But actually, you could do similar things with Bitcoin. And we touched on this when we talked about Bitcoin script and the stack machine. Remember we went through that example where we talked about UTXOs and how you can pay somebody else and how they can check that, they can verify that that address is pointing to them and that they have a right to that output. If you don't remember this, then just go back and watch lecture 1. But you can implement other scripts in Bitcoin. And Colored Coin is one of them. Colored Coins basically said, okay, let's split this Bitcoin. Let me assign this Bitcoin a color. So this color, the color of this Bitcoin is blue. And every time I split up this Bitcoin into its denominations, into the little Satoshis, basically that's a new currency now, right? This is the token built on top of Bitcoin. And the way you would do that is that Bitcoin has specific data fields, arbitrary data fields. You can input any arbitrary data into, like a string or whatnot, and you could just input 1. And from now on, for anybody who acknowledges, who's part of the system, 1 means that you're using this token. And it could be used for specific use cases as well, later on down the line. Other ways you use Bitcoin was assigning them to smart assets, right? You could say, okay, so every Bitcoin with the ID 1, is now part of, now represents this piece of land. And for anybody who's part of that system, that is recognized and that holds additional value. So it is more valuable now to hold a Bitcoin, or part of a Bitcoin, that originated from a Bitcoin that people said is tied to a piece of land. I don't know if that explained that very well, but does anybody have any questions about that? Okay, cool. Just some historical context, right? Okay, and you get to this idea of like, what is an app coin versus a protocol token? Some people call it a utility token. The SEC, which is the Securities Commission, and they're the people who regulate securities. I'm sure a lot of you have heard about them on the news. They actually asked Blockchain at Berkeley to host them recently at Bechtel. If anybody, who's part of that talk? Oh, you went. Awesome. Do you want to say anything about it? Did the SEC, make any claims about securities or utility tokens?
I think they were, generally speaking, quite on the defensive because there's so much pressure from the industry for them to clarify rules and improve, relax regulations. So they were quite on the defensive, and it was clear that they're doing a lot of work behind the scenes.
Yeah, so that was a good summary. The reason I bring it up is because it's not clear right now what constitutes a utility token or what is an app coin. Generally, you don't hear the term app coin online anyway. But what is the difference? And I mean, I don't know if you've been reading this paragraph in the past 5 minutes, but basically an app coin constitutes something that's built on the application layer, whereas protocols are something that are built on the protocol layer. And so, can anyone give an example of a well-known protocol or a well-known application? There are things that act as both. What would you guys say? Okay, so Ether is both a protocol and an application, I guess. The protocol could be that it is a medium of exchange, right? And what does it mean for that to be a protocol, right? It means that you can build on top of it, and it can have some use outside of it just being a medium of exchange. And we're getting into a lot of crypto economic theory right now, but this is a good example, actually. It's an example I point to quite often. Augur and Gnosis. They're prediction markets, basically, gambling markets, but gambling on real-life events. And so the way they work is that they run on an exchange protocol, which a lot of currencies run on, right? So both Augur and Gnosis are built on Ethereum, they're tokens, right? And basically, what ends up happening is they run on the exchange protocol, which any currency does because you can exchange them between actors. So that protocol is necessary for a currency to be a currency. But they also run on a decentralized oracle protocol. And what does that mean? What is an oracle? In any context.
So
In the back.
Input from the real world.
Exactly. So an oracle traditionally is some sort of fortune teller or foreseer. And in the context of blockchains, you need to get information onto the blockchain in the real world in a trustless way. Right? And how do you do that? Well, you get some trusted party. Oh, heresy, right? Trusted in a trustless system. But this is what's required. You incentivize oracles to act honestly and to report true facts to the blockchain. And the way you do that, just to get into a little bit of game theory, is that you have many, many random oracles, right? And you trust that they all act honestly. And if they all act honestly, they're rewarded. And if they act dishonestly, they're punished, I guess. And the incentive model there is that every oracle, or each oracle, does not know who the other oracles are. So they cannot collaborate and come up with one unified fake response. So they cannot all collectively act dishonestly. And also, it is more likely, given a certain real-life event, given that it is rainy today, that most oracles will act honestly and report that it is rainy. It is more likely for all of them to arrive at the truth, a consensual truth, in terms of building consensus, rather than all of them to lie in the same way. Because lying requires that they, fabricate some response. And the chances of all of them fabricating the same response is unlikely. So the oracles, knowing this, will just act honestly. Because even if they want to act dishonestly, there's no way they can incentivize the network to act dishonestly. Does that make sense? Who's confused by that? Awesome. So the protocol here is that is an idea that exists, and Augur builds on top of that in order to implement this betting application. Does that make sense? But it is not only an application, so it doesn't only live on the application layer, because somebody else could then go and build on top of it and use Augur as a protocol for something else. And so this is a nice example because it covers both the application and protocol layer. What's an example of something that is not on the protocol layer? So something that is not on the protocol layer would be a security-like token, right? A security-like token just represents equity in a company. Or even less than that, represents ownership of the token and not equity in the company, right? Because somebody can conduct a token sale to raise money, and actually that generally happens. And this is a comparison between traditional breakdowns in venture economics and the way things have changed since then. But the token could just do nothing, right? It could just represent some promise of later profit. And that's where you have to draw the distinction, right? And some tokens are sometimes construed as being on the protocol layer, but not really. And that sometimes constitutes securities fraud. And I think the SEC has made some arrests in conjunction with that. So if you ever do your ICO, watch out for things like this. Watch out for keywords like utility token, protocol tokens, app coins, whatnot. The other thing I want to talk about in regards to tokens is network fragmentation. Yes?
On that last slide, could you explain why the financial utility curve is going down?
Yeah, so ideally what should happen is that the financial utility, the need to generate profit off of a crowd-sale token should go down as the team really beefs up its application. So people will start using the token more and more for the application rather than the notion of like, oh, this will give me money. Ideally. So like, for example, who holds Ether right now in this room? Okay, a few people. Do you use it to run smart contracts? Who uses it to run smart contracts? Why not?
Because its value grows.
Exactly. It's uncertain right now whether it'll go up or down, but it's too valuable to waste, right? Actually, kind of wrong because like it doesn't take that much Ether to run smart contracts. But whatever, you still want to hold on to every single bit of Ether, and so like you can see how that doesn't really follow this model, even though ideally it should, right? Anyway, back to fragmentation. When you have several applications that take up network bandwidth, because customers are, atomic, right? You can't have less than one customer. And customers' attention usually is not divided between two applications of the same type, right? So instead of people building protocols on top of each other, the harm of not building protocols and building single application level dApps is that you fragment the network, right? It's that you split up people's interests into various projects, and so there's not one unified push behind a protocol that everybody can build on, basically. And there's a lot of talk of incentives and crypto economics again and game theory that we're not going to get into. And again, word on ethics, we talked about the SEC, we talked about being sued, getting arrested. There are huge risks associated with tokens, at least from my perspective, my own personal bias and opinion. Recently, the SEC came out and said that there has not been a single ICO that is not a security. So if you're trying to avoid that securities classification, then good luck. But yeah, watch the 2-hour panel that happened like 2 weeks ago. Interesting stuff. And then examples of red flags are things like overuse of buzzwords, lack of a code base. So blockchain is, as you know, a very like open source and very communicative environment. And if people don't release their code base, well, that's a problem. Like Ethereum has their entire code base online, right? Most legitimate projects do. And so that's something to look out for. Mishandled ICOs, drama. I can click on the link if you want to find out more. But yeah, how much time do we have now? 10 more minutes. Okay, that's enough time to talk about the ERC20 standard. And again, ERC is a request for contributions. So it stands for Ethereum Request for Comment. And it is a filing of like an improvement to the network that some people may develop on eventually. So the ERC20 was kind of a milestone in Ethereum's development because this is the first time that somebody sat down and said, okay, people are making all these token contracts here and there. I want to nail this down though. I want everybody's token contract to at least have the same functionality so you can integrate that across multiple applications. And that's why certain exchanges will only accept tokens to be exchanged on that platform if they're ERC20 compliant. Does that make sense? So yeah, the problem that it was trying to solve in the first place was that many, many people were releasing tokens, and some of them had bugs, and some of them didn't work, and some people would put money into those contracts and wouldn't be able to get that money out. So it's not like somebody was acting maliciously and said, here's my ICO, please give me money. It's that they like didn't think about what happens next. They didn't actually think that it would take off. They didn't actually think that people would put money into it. And when people did, they found out that, oh, shoot, I forgot to program a way to take money out of it. So everybody loses. That's an old estimate, I think, $400,000. I think it's way, way more right now, of like money that's just been like disappeared into contracts that you can't take money out of. And so this should inform the need for a standard, and this standard comes in the form of ERC20. And ERC20, what do I mean by standard? Well, it's just basically every contract has to implement this interface. So every contract has to have a total supply method, a balance of method, transfer, transfer from, approve, allowance, and 2 events, transfer and approval. What do you folks think is the difference between transfer and transfer from? Why is that necessary?
Maybe transfer is whoever calls the function is assumed to be the sender, whereas transfer from you specify an address.
Yeah. So exactly right. So the answer there was transfer is assumed to be you are the owner of those tokens, and so you're going to transfer from your balance to somebody else's. And then transfer from is somebody who has been granted access to somebody else's tokens and will then transfer from their balance to somebody else's balance. Cool, right? And why do you need transfer from? Why is that very, very necessary? So, oh, go ahead.
Maybe if like the owner goes AFK, maybe the partners be like, dude, why are you AFK? We can't take any of the money out.
So AFK means away from keyboard. It means inactive. yes, that's a good example. A more solid real-life example is you're an exchange, and your user wants to tells you, transfer some money for me to that person over there. You've structured your architecture such that the user doesn't have direct control over their own funds, because that would be kind of silly. It's like the way Coinbase does it is that you don't have control over your own private keys, which is one example. The exchange still needs a way to be able to take the tokens out of your account and put them in someone else's. And actually, for a lot of dApp integrations, you need that permission. You need to be able to move around different people's tokens, especially if you're the person who deployed the contract in the first place. If you're the company, and people want you to do stuff for them, you need to be able to do that stuff. Anyway, I think we're running short on time. There are extra fragments that people can add on top of the ERC20 standard. And so, yeah. These come in the form of an actual token name, a token's ticker symbol, and then the amount of decimal points that can be specified. And why is that important, the number of decimal points?
Maybe it's like the smallest denomination of that token that you can give out.
Exactly. You want to be able to specify, fractional denominations. And if you'll have noticed that Ethereum doesn't really have, decimal places or floating point operations. Viper does, so look forward to that. But Solidity doesn't, and so you just have to, specify how many decimal points of tokens you're giving someone. And we have an entire example, but I don't think we have enough time to cover that. So we'll just go to questions. And that's it for the lecture. So next lab, we're going to talk about more tokens. We're going to go through the example. Also, next lab will be your midterm assignment. The reason I put it in quotes is because it's just going to be an assignment that'll take you a little bit longer, like 2 weeks or something. So don't worry about it too much. Yeah, and any questions on this lecture or anything else? Sorry, I can't hear you at all.
For contracts to give other address permission to withdraw funds, we'll programmatically include that. But if I have a wallet account, not a contract account, and I want to give someone permission, is there a way to do that?
Yeah, so for example, you would ping you'd ping the company and tell them whom you want to give a permission to, and they would manually do that on their end. Yeah, since they control your wallet and whatnot. Okay, thanks. Feel free to come up here and ask questions or leave or whatever.
Quick question, Matt.